All right, hello AP Stats students from around the country, and welcome to the College Board Virtual Instruction for AP Statistics. My name is Luke Wilcox. I am an AP Stats teacher at East Kentwood High School in Kentwood, Michigan. I hope that you were able to log on yesterday and check in with my colleague, Mr. Brendan Murphy. He and I will be sharing the duties of covering these lessons. And I think we are ready to jump right into things today. So we're going to go ahead and get started here. So just to check to make sure that everyone is in the right place, this is AP Statistics. As I have mentioned already, my name is Luke Wilcox, proud teacher at East Kentwood High School. And I'm going to start with a couple of reminders. If you've been with us for the last couple of weeks, you may already know this, but if we have anybody that's new to us today, I just want to make sure you know where we are in the sequence of instruction here. We are meeting Monday through Friday on a daily basis at 2 o'clock. All of these videos are also available afterwards as recorded videos. And right now, we are in the middle of our AP exam review. We just started on Monday, and we are currently in this first week of April 6th to the 10th, where we will be covering units 6 and 7 from the College Board CED, which would be the inference for proportions and means. There's a good chance that your teacher already got to this content, but there is also the chance that your teacher did not get to this content before the end of the year. So that's why we're starting our AP exam review with units 6 and 7, which will be contained on the AP exam for 2020. It's the final 2 units of 8 and 9 that will not be covered on this year's AP exam. Now, after we finish unit 6 and 7 this week, then starting next week, we are going to go way back to the very beginning of the course and go in order units 1 through 5. And we actually have 3 weeks to get through all of that stuff there. So by the time we are done on May 1st, we will have taken you through all of the content that will be covered on the 2020 AP Statistics exam, which we now know is going to be on May 22nd. That is your AP Statistics exam. Couple of other quick reminders, all the resources that you might need for these lessons, you can find at statsmedic.com/YouTube. That's where you can download the lessons if you want to print those out. You'll also have access to the homework questions that you'll see available on this website. And then finally, if you or someone that you know might be in need of a device or internet access in order to be able to take that AP exam on May 22nd, there is a website here that you can go to, or you can have your friend go to. The College Board is very committed to making sure that every student has access to a device and internet access on the day of the AP exam, because these exams will be taken at home. Okay, now that we have those reminders out of the way, I think we can jump into the homework problem that Mr. Murphy gave you yesterday, which is also a very good preview of what's to come in the lesson that you're going to see here today. So let's jump right in. Follow along with me here. It says a test engineer wants to estimate the mean gas mileage. So right away, I know that I'm trying to estimate a mean rather than a proportion in miles per gallon for a particular model of automobile. 11 of these cars, okay? Sounds like our sample size is 11 here, are subjected to a road test, and the gas mileage is computed for each car. A dot plot of the 11 gas mileage values is roughly symmetric and has no outliers. The mean and the standard deviation of these values are 25.5 and 3.01. Okay, let's pause right there and let's make sure that we know exactly what we're getting here in the problem. This 25.5 is a mean, but because it's a mean calculated from a sample, we're going to call that X bar. And then the 3.01 is a standard deviation, but it is the standard deviation of a sample, so I'm going to be using S there. And it says, assume that these 11 automobiles can be considered a simple random sample of cars of this model. Which of the following is a correct statement? And very clearly, when I look at the answer choices here, they're wanting us to think about calculating a confidence interval here for the mean gas mileage. And so I'm going to remind you of a couple of general formulas that are always true for any confidence interval that we're trying to calculate. The first of which says that the general way you construct a confidence interval is to take some sort of guess, which we call our point estimate, and then to add and subtract a margin of error to account for sampling variability. Now, there's another version of this that you will get on the formula sheet for the AP Statistics exam, and it looks like this. It says statistic plus or minus the standard error of the statistic. Now, let's try and make this formula more specific for the thing that we're trying to estimate, which is a mean. So for us, the statistic is going to be the mean of the sample. That's our best guess, plus or minus. Now this, oh, I'm sorry, I missed a value in here. The standard error of the statistic, there's another value that comes before that, which is the critical value. So it's the critical value times the standard error of the statistic. I need that critical value, which tells me how many standard errors away from the mean we need to go in order to capture 95%. So that's T star. And then the standard error is S over the square root of N, which you can also find on your formula sheet. So that's the format. Now you'll look, all of the answers sort of follow that format, except answer choice E, which says the results cannot be trusted, the sample is too small. Well, I do have a sample of only 11, and I seem to remember that we would like to have a sample size of 30 or more in order to know the sampling distribution is approximately normal. But if our sample size is small, we can look at the sample data to check that there's no strong skew or outliers, which sure enough, they tell us that the dot plot is roughly symmetrical and has no outliers. So our normal condition is going to be satisfied here, and the sampling distribution will be approximately normal. So this really isn't an issue. That's not going to be one of our possible answer choices here. Now, as I look at the 4 other answer choices, right away, I'm noticing that in the bottom, underneath the square root, I see 11s and I see 10s. And I know that it's supposed to be my sample size, which we know is 11. So this right here is incorrect. So I'm going to get rid of answer choices C and D. And I'm left with just answer choices A and B, and I notice the only difference between those two is this T star critical value. And here's the deal with the critical value. In order to calculate the critical value, we have to know the degrees of freedom, which is given by n minus 1. So for us, the degrees of freedom for this problem is 10. Now we would take that and go over to our formula sheet here, which is the formula sheet that's given to you on the AP exam. And I'm going to go over until I find table B, which has my critical values, the T distribution critical values. And the way this table works is that you have to know your degrees of freedom. Well, we know our degrees of freedom is 10, and we know the confidence level that we want is 95%. So if you find out where those come together, they come together at 2.228, which is how many standard errors we need to go away from the mean to capture 95% of the data. That is our T star value. So let me go back and check which one of those has the correct value, 2.228, which is answer choice A, because answer choice B has the wrong critical value there. So our final answer on this multiple choice question should be A. So I hope that you did all right on that homework problem, and you are now ready to jump into some new learning for today, which is going to be related to this homework problem that we just did. So let me give you the quick overview of things. This is where I give you the learning targets for the day, and they are very straightforward here. There are 2 of them, okay? And both of them are about constructing and interpreting confidence intervals. But you'll notice that the first one is to construct and interpret a confidence interval for a population mean, and I'm talking about one mean there. Whereas the second learning target is a confidence interval for the difference of 2 population means. So there you are going to have a 2-sample problem or an experiment that utilizes random assignment. Now, for both of these learning targets, I'm going to use the familiar, hopefully familiar to you, 4-step process of state, plan, do, conclude. So here we go. Here is the activity for the day, and it is an AP Statistics versus AP Calculus battle here, and the question that we're trying to answer today is, how will you prepare for the AP exam? Or more specifically, how much time will you spend preparing for the AP exam? So here's what it says. A random sample of 20 AP Statistics students from last year was asked to share the number of hours they spent preparing for the exam. Here are the results. Okay, so right away, I've got this number 20. That sure sounds like our sample size. I'm going to call that N. And let's take a look at the results here. Okay, so we get a dot plot. And I notice in the dot plot, it looks like it's maybe fairly symmetric. Doesn't appear to be any outliers there, but I'm also given some summary statistics here. And sure enough, here's our sample size of n. Here is the mean of the sample, so let's be careful with our notation here. This is x bar because it is a sample mean. And then the standard deviation that's next to that, that is a sample standard deviation, which is s. So let me pause right here and make note of one thing. This is going to be different for estimating means than for estimating proportions like we did earlier this week. And here's the issue. Not only are we trying to estimate the mean of the population, but we are now also having to estimate the standard deviation of the population because we don't know sigma, the standard deviation of the population. So when we standardize a statistic, we now have two values that are varying according to the sample, which is the sample mean as well as the sample standard deviation. And this is why we are going to be left using what's called a t-distribution rather than a normal distribution. And so that's why that critical value is going to be a t-star critical value rather than a z-star critical value. And just to be clear, the reason why we're having to use that is that we don't know sigma, which is the standard deviation of the population. All right, so here we go. Construct and interpret a 95% confidence interval for the true mean number of hours spent preparing for the AP exam for all of last year's AP Stats students. Okay, we're going to start by identifying the parameter, which is mu. This is the thing that we're trying to estimate here, and that is the true mean number of hours spent preparing for the AP exam for all of last year's AP Stats students. Now, one thing I want to point out here is I'm being very careful with my language here to make sure that I'm referring to the population and not the sample. And so I use the word true and I use the word all to make it very clear that I am referencing the population. We are trying to estimate something from the population here. Now, our confidence level, of course, is given to us in the problem. This is the familiar 95% confidence level. All right, as far as the name of the procedure, first thing to notice is that we only have one sample here. So this is a one sample. It is an interval, and we have to decide whether it's a z interval or a t interval. And we've already talked about why this has to be a t interval. And then let's also specify what it is that we're trying to estimate here, which is a mean, a true mean, mu. All right, so we are now ready to check conditions, and these are going to look hopefully very familiar to you. We are going to start with the random condition, which is where we check that we do in fact have a random sample. And this is given to us right in the wording of the question, right up top here. So I'm just going to steal the words right from the question, which tells me that we have a random sample of 20 AP Stats students. Now, the reason why this is important, I call this the so what. We need a random sample so that it is representative of the population so that we can generalize our results to the population, right? That's the value of having a random sample. All right, next up is the 10% condition, which we need to check if we are sampling without replacement. And in this case, I'm sure that we didn't take one AP Stats student and then put them back in the pool after we sampled them, right? So once they're taken out, this is without replacement, which means that we do need to check the 10% condition here. And so we would check that our sample size is less than 10% of the population, which is all AP Stats students from last year. And well, we know well that there are hundreds of thousands of AP Stats students. And so definitely the 10% condition is going to be satisfied. And the so what here is, so this idea of sampling without replacement is okay. That's not an issue. We don't have to worry about independence because the sample size is small relative to the population. And the third condition, which I'm going to call the normal or the large sample condition, is where we're checking to make sure the sampling distribution is approximately normal. And ideally, I'd like to have a big sample size of, say, 30 or more. But in this case, we do not. We only have a random sample of 20 students. So when your sample is smaller than 30, you have to look at the sample distribution to make sure that it appears like it could have come from a population distribution, which is approximately normal. So specifically, you're looking for no strong skew and no outliers, which I think we see here definitely in the dot plot. And so the way I'm going to justify this is I'm going to say that the sample distribution, notice I'm saying sample distribution, not sampling distribution, because I'm just talking about the distribution of our sample of 20 students. The sample distribution shows no strong skew or outliers, which means it's reasonable that this sample data may have come from a population distribution, which is approximately normal, which then allows us to say that the sampling distribution is approximately normal. So that's the so what. The sampling distribution is approximately normal. So with our three conditions satisfied here, we are now ready to actually go ahead with a calculation. So let's move down to where it says general formula here, and I will start with the most general formula for calculating a confidence interval, which is to make a guess from our sample. That's called our point estimate. And then to add and subtract a margin of error, which will allow us to account for sampling variability. Now, on the formula sheet for the AP exam, you have a different version of this, which is statistic plus or minus your critical value multiplied by the standard error of the statistic. And we are ready now to give us our specific formula. The statistic here is X bar, that's our sample mean. We know the critical value has to be a T star value. And then the standard error, which is also on the formula sheet, is S over the square root of N. So we're ready to plug in some numbers now. We know our X bar, if I look back up here, it is 11.4. Now, I do need my T star value here. And in order to get that, I need table B, and I need to know the degrees of freedom. And we said that the formula for the degrees of freedom is N minus 1. Our sample size here was 20, which means that our degrees of freedom is 19. So if I go back over to my table B here, and now I'm looking for, let's see, degrees of freedom 19. And once again, I want 95%. So it seems to me that 2.093 is my T-star critical value there. So let's go back and fill that in. 2.093. My standard deviation S, I can look up above, is 3.719, all over the square root of N, which is going to be the square root of 20. Now, I punched these numbers in my calculator already here. 11.4 plus or minus a margin of error of 1.74. And that's going to allow us to arrive at a final answer of 9.66 up to 13.14 as our confidence interval. Now, as far as interpreting this confidence interval in our conclusion, it's going to look very similar to what we did when we were estimating proportions. So here we go. It says we are 95% confident that the interval from, and this is where we give the actual values of the interval here, it's 9.66 to 13.14. But let's be careful to include units here, right? We didn't have to worry about that with proportions because proportions don't have units. But here we do have units. We're trying to estimate the number of hours. So this is going to have the units of hours. And then we want captures the. Now, the thing we're trying to capture, remember, is the parameter, which really just comes from the wording of the question. So I can literally steal these words from the question and bring those down into my conclusion here. So I'm going to say the true mean number of hours spent preparing for the AP exam for all of last year's AP Stat students. So let's talk real quick about what the rubric might look like. So I went back and I perused a few of the old rubrics on the College Board website, and it tends, there's some tendencies of things that you'll always notice they're looking for on the rubric. First of all, somewhere you have to identify the correct procedure. And of course, the easiest way to do that is by mentioning the name of the procedure. But you can also get credit for identifying the correct procedure right down here where we've shown the formula that we're using. Now, you don't have to have both. You got to have one out of the two. That identifies the correct procedure. Next up on the rubrics typically is that you're going to have to check your conditions. Now, if you look back at most of the rubrics, they will talk about the random condition and they will talk about this normal large sample condition. It was only last year where we first saw the 10% condition show up on a rubric, which I think now will be the standard if you are sampling without replacement. So in this case, you want to make sure you have all three of those conditions checked. And then, of course, the rubric is going to check to make sure that you have the correct interval, which is your answer here. So realize that this answer is the thing that is going to be graded. And some of this work that we have here is not necessary in order to get full credit. Although I really like having it, I like showing it. It helps you catch mistakes if you're going to make a mistake, but it is not required in order to get full credit there. And then finally, you have to have the correct conclusion. And there's a couple of things that we want to look for in this conclusion. First of all, let's make sure we're using the word confident and not the word chance or probability there. We want to make sure that we have the correct units here because we're estimating a mean. We need to make sure we're referencing the population here, which I use the words true and all. And then also make it clear that we're trying to estimate a mean here rather than a proportion. And then you want to make sure that you have some context to the question somewhere in your conclusion there. Now, I'd like to also show you how you can do this on your calculator. So if you want to grab your calculator, you can do that. If you want to just follow along, I'm going to show you everything that you need from the calculator in order to check this confidence interval. Okay, so here we go. We need to go to the stats menu, so go to stat, and then go over to tests, and you'll notice that most of the first ones are tests, and then you get down to the intervals. And sure enough here, we want a t-interval. So this number 8 here is a t-interval for a mean. That's exactly what we want, a one sample t-interval for a mean. So I'm going to hit number 8. And you have the choice of inputting all the individual values of the data by putting that into a list. We actually have the summary statistics, so I'm going to go that route because it'll be just a little bit quicker here. So let's start with the X bar value, which was 11.4. That's the sample mean. The standard deviation was 3.719. And we know the sample size was 20. And the confidence level that we want for this one is a 95%. So let me change that to 95%. I'm going to go ahead and hit calculate here. And sure enough, the calculator answer matches with what we had in our work. We had 9.66 to 13.14, which is precisely what you see here on the calculator. So I think this is a great way to check your answer. If you made a mistake somewhere in your work, you know to go back, look at that work, make sure that it matches up with what you see on the calculator. All right, I think we are ready now to jump into our second type of confidence interval here, which is now going to be a two-sample problem. So if you flip to the next page there, let's take a look at what we have here. All right, so it says, random sample, 20 AP Stat students from last year revealed they spent an average of 11.4 hours preparing for the exam with a standard deviation of 3.72. Okay, we already knew that from the first page, right? A separate random sample of 40 AP Calculus students from last year revealed an average of 9.1 with a standard deviation of 2.94. So very clearly here, we have two separate independent random samples. So let's get our notation down right away here. 20 is our sample size, but it's the sample size from the first sample, so I'm going to call that N1. 11.4 is the mean X bar of the first sample, so I'm going to call that X1 bar. And then the standard deviation over here is S1. And then we go to the AP Calculus students. 40 is going to be my N2 value. 9.1 is going to be my X bar 2. and 2.94 is going to be S2. So here's what we're trying to find. Construct and interpret a 90% confidence interval for the true difference of mean number of hours spent preparing for the AP exam for all of last year's AP Stats and AP Calc students. Okay, difference of means is what we're looking for here, all right? So in terms of our sample means, the difference of the means would be x1 bar minus x2 bar, which would be 11.4 hours for AP Stats, 9.1 hours for AP Calc, which is telling us that AP Stats students from our samples spent about 2.3 more hours on average. Now that's from the sample. Now we want to try and estimate what that difference would be for the whole population. So the parameter we're trying to estimate this time is the true difference in means, mu1 minus mu2. So I'm going to call that the true difference of mean number of hours spent preparing for the AP exam. And listen, this is where I'm going to make it clear which way I'm subtracting. We did AP Stats minus AP Calc. So I want to make sure that that's clear in my solution here, right? Because we could have done it the other way around, but I like doing it in the order that it was presented here. So the confidence level was given to us in the problem here. We're going to go 90%. All right, as far as the name of the procedure, okay, what's different here than the previous confidence interval is that now we have two independent samples. So this is a two-sample T interval, and the thing that we're trying to estimate here is mu1 minus mu2. Now the conditions are going to look very familiar to you. We are going to check the random condition, the 10% condition, and the normal large sample condition. The thing here is we're going to have to do twice the amount of work because there are two samples here. So the random condition, we do have two random samples. It's also very important to state that those two random samples are independent of each other. And that'll become important when we look at the formula for the standard error. So independent random samples of 20 AP Stats and 40 AP Calc students. So we would say that that condition is satisfied, making note that we have included the word independent there. All right, 10% condition, sampling without replacement, both of the samples, got to check twice here. We already did it for AP Stats, but let me just record that. 20 was less than 10% of all AP Stats students. But now we need to also check the 10% condition for the AP Calc students. So 40, less than or equal to 10% of all AP Calc students. So our 10% condition satisfied here. Now for the normal large sample, we have to check it for each sampling distribution here. We already did it for AP Stats. So I'm just gonna write down what we had on the previous page, which was to say that the sample distribution, right, that dot plot that we had on the previous page, had no strong skew or outliers. Now for AP Calc, we have a much bigger sample size here of 40, which is beyond our value of 30, right? So this is a large enough sample that we'd be comfortable to say the sampling distribution is approximately normal for the sample means for the AP Calculus students. So we're just going to say here that the sample size is large. And to make that very clear, by large, we mean that it is greater than or equal to 30. Okay? So our normal large sample condition is satisfied, and we can say the sampling distribution of the difference in sample means is approximately normal. All right, let's move to the do. And the general formulas are going to look exactly the same as they did on the previous page. Point estimate, plus or minus the margin of error. And then we have our formula from the formula sheet, which says statistic plus or minus the critical value times the standard error of the statistic. Now, the specific formula is where we're going to have to do a little bit of work here. The statistic this time is the difference in the sample means, x1 bar minus x2 bar. Critical value, because we're still dealing with means and we have to use the standard deviation of the samples because we don't know the standard deviation of the population. It's going to be t star. Now, the standard error, I just want to quick show you on the formula sheet where this is. Formula sheet here, it's on the second page. You can see on the right-hand side, we've got the standard error. And so here I'm looking at standard error, and we want two populations. And so look, this is it right here. So we're just going to copy that over for our standard error, which is the square root of S1 squared over N1 plus S2 squared over N2. What we're really doing there is we're adding the variances of the two sampling distributions, which we are allowed to because they of the independent random samples. Now let's plug in some numbers here. 11.4 minus 9.1 plus or minus. Now T star, we need to know our degrees of freedom, but we have two different sample sizes here. So you might say, well, maybe the degrees of freedom is 20 minus 1, or maybe the degrees of freedom is 40 minus 1. Now, oops, I'm sorry, 40 minus 1, which would give us 39. Now, there's two different ways that we can approach this. I'm going to show you the way sort of to do it by hand. We call this the conservative approach. It is more conservative to use a lower degrees of freedom here. And so we're just going to take the lower of the 2 degrees of freedom, and let's start with that. And then later, I'll show you how we can use technology to get an exact degrees of freedom. But for now, let's use 19. So I'm going to go back to my table B, and now I have degrees of freedom 19. Okay, so we're back at 19, but now I need 90% confidence interval. So I'm seeing a 1.729 as my critical value. So let me go back, and we can fill in our T star 1.729 and plug in some numbers here. It's going to be 3.72 squared over 20 plus 2.94 squared over 40. So I did these calculations already. I got 2.3 for my point estimate, and I got 1.65 for my margin of error, and that is going to give me a final answer of, let's see, 0.65 up to 3.95. And I think we are now ready to make a conclusion here. All right, so here we go. We are 95% confident that the interval from 0.65 to 3.95, once again, we need units here because we're trying to estimate a difference of means. Units are hours again. And we're going to say captures the, and now we're just going to go back to the wording of the question, and word for word, we're trying to capture the true difference of mean number of hours spent preparing for the AP exam for all of last year's AP Stats and AP Calc students. And we have one final question to be able to answer, hopefully using this confidence interval. It says, based on the confidence interval, do we have convincing evidence that AP Stats students studied more than AP Calc students on average? Well, listen, take a look at our interval here. These are the plausible values. These are the values we think are plausible for the true difference in means, all of which are positive, right? And a positive value here would indicate that AP Stats students are better. I mean, AP Stats students studied more than AP Calc students, right? All positive values, no negative values here. So, of course, the answer is yes. And we'll say this, because all of the plausible values in the 90% confidence interval are positive, that means we have convincing evidence that AP Stat students studied more than AP Calc students on average. All right, now I do want to show you quickly how you can check your answer here on the calculator, and also show you something new that the calculator is going to give you that we don't have in our work shown here. So let's take a look at the calculator. And now we're going to be not doing a 1 sample t interval, but a 2 sample t interval. So go over to stat and then tests, and you're going to have to scroll down until you can find a 2 sample t interval, right, which is 0 here, 2 sample t interval. Once again, you could input data into lists, or you could use your summary statistics. And we have our summary statistics, so let's go ahead and use those. So the sample mean for AP Stat students was 11.4 with a standard deviation of 3.72 and a sample size of 20. Now for the AP Calc students, they had an average of 9.1 hours with a standard deviation of 2.94 and the larger sample size of 40. Now, where it says pooled by default, oh, I'm sorry, let's get our confidence level. We want that to be 90% here, don't we? 0.90. Now, for pooled, by default, it should be on no. You should leave it there, okay? The reason you use pooling is if you, for some reason, thought that the standard deviation of each one of those populations was the same, then you might pool the 2 samples together. But for AP statistics, you will not be making that assumption. So just leave that on no. And then go ahead and hit calculate. Now you're going to notice that this interval is slightly different than the one that we got by hand, and it's because of this degrees of freedom right here. Okay, the calculator has this big, long, fancy formula that it uses to find the actual degrees of freedom, which is going to change your interval just a little bit here. Okay, but for the most part, we had 0.65 to 3.95, very, very close. So let's go back to our activity, and let's at least record these values that we got from the calculator, just so that you have this in your notes here. It's a slightly different interval, okay? So I'm gonna record this down here. The interval that I got from the calculator was 0.69 to 3.92, okay? This is from the calculator. And I should also indicate the different degrees of freedom that were used there. The degrees of freedom that the calculator gave us was 31.24. Now listen, if you're gonna use that answer, then some of your work now would be incorrect, right? This t-star value isn't quite right. So if you are gonna use your calculator work there, you're gonna wanna, you're not gonna wanna show this work here, right? Or you know what you could do is you could just leave this as a t-star value, and that would be, everything else would be correct. Now you would have to recalculate this margin of error here, right? So that's up to you on the AP exam, both the conservative approach to the degrees of freedom as well as the fancy approach using the big long formula. Either one of those would be accepted on AP exam. All right, I think we are finally ready to try and summarize hopefully what we learned here in the important ideas. And I'm just gonna go back to the 2 learning targets that we started with at the beginning of the lesson. And we're just gonna like split this thing in 2 here. And I'm just gonna make a little table to remind us of some things here, okay? Learning target number 1 was about calculating a confidence interval, but for 1 sample. So that was a 1 sample t interval for mu, a single mean. Learning target number 2, we had 2 samples, and we were trying to find what's called a 2 sample t interval for the difference of proportion, or difference of mean, sorry, which is mu1 minus mu2. Now, the way I'd like to organize this table, let's start by identifying the parameter for each one of these confidence intervals. For a 1 sample, it's just going to be 1 mean here, mu, which is going to be the true mean of something, right? Like some sort of context. Whereas the two sample, the parameter we're trying to estimate, is mu1 minus mu2, which is the true difference of means, and then some sort of context. All right, next up is to make a quick list of the conditions that are necessary, and there are 3 of them. We have the random condition, we have the 10% condition if sampling without replacement, and then we have what's called the normal large sample condition. And I think it's worth making a quick note about this normal large sample condition. There's actually 3 different ways that this condition could be satisfied. The easiest way is sometimes in the problem, they will tell you that the population distribution is approximately normal, which would automatically mean that the sampling distribution is approximately normal. The next best way that you can get it is if your sample size is large. And when I say large, I mean that it's greater than or equal to 30. And the third way, which we had to utilize with the AP Stats sample, was that the sample data shows no strong skew for outliers. All right, so let's move over to the 2 sample stuff. And let's see, the conditions there are the same, but they're twice as much work, right? Because now you have to check each one of these conditions 2 times. So I'm just going to make a note here that each one of these has to be checked twice for each one of the random samples. And the other thing too is that for the random sample, we want to make sure that those 2 random samples are independent of each other. Quick note too on the random condition, we could also have an experiment that utilizes random assignment into 2 groups, in which case it would be a 2 sample t-interval. Okay, the final thing that I'd like to record here is the specific formula for the confidence interval. For 1 sample, you got x bar plus or minus t star times s over the square root of n. For the 2 sample, we have x1 bar minus x2 bar plus or minus t star times this big formula for standard error, which is s1 squared over n1 plus s2 squared over n2, and then square root that whole thing. So the check your understanding problem you see there is your homework problem. That'll be the first thing that Mr. Murphy will do tomorrow, is to go over that answer with you. I hope that you enjoyed the video today. I hope that you got something out of it. If you did, give me a thumbs up there. Please check in with Mr. Murphy tomorrow at 2 o'clock, and then I will be back with you again on Friday. See you then. Have a great night.